as Olivier said, I have had a diverse background, and unlike my colleagues here, I once was an academic for about 10 years, mostly at INRIA, and then I left academia to start a company and become a CEO of a startup company. Lasted for 8 years. That company was acquired by a large corporation, and for 5 years now, I'm with another startup called SAP. We are 60,000 employees. So I've seen pretty much all facets, I guess. And this is a very personal talk, really. Today here, I'm probably not representing totally SAP itself, but really talking about my personal subjective experience with research, innovation, and entrepreneurship. So, my academic career started with the needle in the haystack problem. Mostly, which is a well-known problem in all disciplines of computer science, but my interest was mostly in multimedia and image recognition. And so the academic problem that I have always tried to solve back in the last century was finding a needle in the haystack, especially difficult problem when you have no alphabet, like in the case of images. And so how can we find that? This, of course, has led to tons of literature and approaches on how to do this. And I will briefly explain how we do this and what are the approaches, because this is both about my academic work and my startup work. Essentially what you do, and many of you might know this, what you do is you do indexing by content of the image. So you extract a number of visual characteristics of the image based on interest points, based on color and gradients, shapes, texture, and so forth, and you extract a signature, a very compressed index, and you store that. And that index is going to represent your image and thereby allow you to compare your images or classify them. Okay, so it's a classic pattern recognition problem. Now, when I was an academic, I was, of course, developing and writing these papers with my team, and we were very proud of the results that we had, and this, some kind of early prototypes that was working well, and it gave us confidence to start a company. And we started a company exactly based on our research, as everybody would do, right? You're good at something, you start a company based on that something. And so we said, okay, what is it that we can do with this kind of research of image recognition? Well, one of the first things that you can do is to do what we call image matching, is to find the same instances of the same image, no matter scaling, noise, rotation, and etc. So in this case, finding the algorithm will indeed find that these are all the same pictures, including that tiny one on the top right. This, of course, has a number of applications, finding this image on the web, let's say, or simply doing, bypassing the whole QR code problem for linking a real-world advertisement to a website. Right? You can take a picture of what you like and have information on it on the web by linking a specific URL. What else can you do? Well, you can also do image similarity. And image similarity is about finding images that are similar to the query image. So your query this time is not a text, it's an image. Let's say it's the top left query, and you're finding in this shop the similar T-shirts that they have to offer, a bit like a salesperson would do, right? You're interested in that red T-shirt. Well, we have also these others, trying to help you finalize and close the deal, and tick on that buy button. Okay, and if we want to do in a completely different industry, if we want to do something even more sophisticated, I guess, in terms of science, what we would do is object recognition, which is the holy grail of what we do. Recognizing objects, just like your eye and your brain would do. This is a real-world example from a customer of the company. This customer is actually law enforcement customer, the police, in this case for trafficking of stolen art. In this case, the investigator is going to an antique shop somewhere, suspicious antique shop, and taking a picture of especially an object that he is interested in, the investigator, and he wonders if this is a stolen object that is in fact being sold in this antique shop. So he takes this picture and he compares this picture to a database of stolen objects in the past. And what he finds in the database, which of course contains a lot of images, is a match for that image. So on the left-hand side, you have the cropped image that the investigator took, and on the right-hand side, you have an image of the same objects taken 10 years ago, before, of course, this object was stolen somewhere in a museum or someplace. And our system in this case, despite being in a haystack and having thousands and in fact millions of images in the database, was able to extract and find the same picture. And so the answer is yes, this is a stolen image, and the sale was stopped in this case. Okay, of course this makes the case for taking the picture of everything that you think could be stolen. So if you think something might be stolen, take a picture. It could be useful. Okay, so in fact, I don't want to spend too much time on explaining, how I raised money, because yes, I did raise about 7 million euros. How I, why I quit academia, maybe we can discuss that later. I'm really building a product company, software company in this case, with venture capitalists and, the whole 9 yards. I don't want to discuss either the product offer of the company. I don't know if that's so interesting. What I really want to discuss in this presentation is the lessons that I have learned here. Okay? And so just to finish on the company, if you're really curious and want to know more, since I won't be talking too much of them, the company is called LTU Technologies, ltutech.com. This is their website. And the company was acquired by Jastec Co. Limited, which is a very large listed Japanese corporation. That no mask is the symbol of Jastec. And so this company based out of Tokyo approached us in 2005 and acquired us. It was a very, very successful exit. So in this case, it was completely a success for the founders, the venture capitalists, INRIA, everybody. Okay? But apart from the story itself, as I said, I want to focus on the lessons that I have learned. And, looking back, my question would be, is there really, do you guys think there's a real continuous 1D line between fundamental research and applied research? We would have, something like people wondering if P is equal to NP on the left-hand side, and on the right-hand side, suddenly you are deploying recommendation engines for Amazon.com. Is that really the case? And by the way, what about these other terms that apply to research, such as pure research, technological research, industrial research? I've always myself had a lot of trouble understanding the nuances there. Turns out that after years of wondering that this can't be right, I was comforted in this idea that this is indeed not right. This is not a 1D problem at all. In fact, I read a book, which I recommend to all of you, called Pasteurs Quadrant. Many of you might know this book, by Donald Stokes in 1997. And this, Stokes explains that the problem is in fact 2D. It's as simple as that. On the x-axis, you have the considerations of use. On the y-axis, you have the quest for fundamental understanding of the problems. And so like in any good MBA course, you get 4 quadrants here. This is the quadrant you don't want to be, because this is the loser's quadrant. This quadrant is called the Edison Quadrant. I'm always fond of quotes of famous people. And so Edison famously said, "I don't want to invent it if it's not useful." So he was really obsessed by usage here. And to the contrary, the top left quadrant is the quadrant that Stokes called Bohr's quadrant. Niels Bohr is a recipient of the Nobel Prize in 1922. He famously said, "Everything that I have ever written in my whole life should be seen as a series of questions to myself." So he was really trying to understand nature, physics. And so, since you know the title of the book by now, you won't be surprised. The top right quadrant, which is where you want to be, especially when you come from research, is Pasteurs Quadrant. And Pasteur famously said, "Chance only favors the prepared mind." Okay? So what does this tell us? To me, it actually tells us a lot of things. It actually solves all of our questions about research, innovation, entrepreneurship, etc. Because essentially what this is saying, if I extrapolate just a little bit, is that researchers are on the y-axis and engineers, or maybe businessmen, or on the x-axis. So there's some sort of orthogonality between being an entrepreneur and being a researcher. Could argue that, in fact, we're saying science versus business. Science as business is not a continuous line. These are 2 dimensions of something that you're trying to do. Okay, nice. But are they similar or are they orthogonal, as we just saw? Well, I think they are similar. They seem orthogonal, but they are both based on the bottom-up talent to first observe and then only design. And this is the single message that I'd like to give to you as an advice. The way you want to do it is first observe and then design. And this sounds very easy because you are all scientists. But in the business world, in the entrepreneur world, it's difficult. It's difficult especially for you, because you are a technology expert in this room, I guess, and your natural tendency is to showcase a technology solution looking for a business problem. This morning we had a question from a lady who was asking, how can I find somebody to promote my ideas? I think the problem is there. I don't think the problem is there. You cannot start with your ideas. You cannot start with your technology. You shouldn't start with your expertise to begin with. Because guess what? If you do that, let's do that. We have an excellent expertise, PhD plus 3 years of postdoc in something, okay? And if we start from there, I call it number one on the y-axis, then it might end up here. No use, not so interesting. Nobody buys it. You think it's great, and it is great, scientifically speaking, but business-wise, 0. This happens all the time. And the main problem with scientists starting a company is that they do exactly this. I did this myself. I started because I had this technology I was proud of, and I said, okay, there's got to be something, an application. This is the typical introduction of computer science papers. Digital libraries have long been researched, blah, blah, blah. And there are tons of applications, of course, of the meta. You know, we have all written this paper, right? Let's be honest. Okay? But this doesn't work. It's just not cosmetics here. So this is the top-down approach, the wrong one. The correct one, the bottom-up approach. Bottom in this case is the business value that you want. You start from the business value, something important, a very burning problem, something huge potentially. And you say, okay, what I need for this is a website, let's say. That's not too difficult. That, you know, has a search box. Okay, that's not hugely difficult. And with that, I'm gonna, going back to the Amazon example, recommend items to the Amazon customers. And that's kind of difficult if you want to do it right, at a large scale. So the first question, this seems obvious, of course, after the fact, but is what is the problem I want to solve? And is my PhD helping in any way to solve that problem? It probably won't, it will not never be a 100% match, never. It's wrong if it's a 100% match. You will need a lot of other technologies, some simple, some complicated. Okay. That was the part on my entrepreneurship. I hope it's not too disappointing. But I'll give you at the end my top 10 recommendations for entrepreneurs from research. I want to now introduce SAP, which is the company I work for about 5 years now. I don't want to introduce SAP by the numbers and, you know, revenue and margin. We're not here for that. I want to introduce SAP more in terms of domain of activity or science. SAP is grounded in data science, really, right? If we think of data, if we add semantics on top of data, that we call that information. Information, if it's relevant and if you can trust it, as a user, you build knowledge upon it. And if you have a strategy based on your knowledge, you can make a decision. If you have the means of action for the decision you just made, you can make an action. If you execute your action, you'll generate data. This is what I call the data cycle, and this is exactly what SAP is doing, because this part on the bottom right is the world that we call, in the enterprise world, the world of transactions, the world of enterprise applications, the ERP, for those familiar. Okay? And this world here is the world of business intelligence. This is forward-looking. Analytics is a synonym nowadays. And so the whole objective of making sense of data and shedding light into your business for you to make better decisions. And who's you? Well, it's a human user and sometimes a very intelligent machine. Okay, so this is where the company operates, and this is where nowadays a lot of companies operate in the analytics world, not only in the enterprise analytics world. Okay, a few words about research at SAP. I always keep in mind that we have to do two things when we do research at a company, right? We have to do research, which is using money to create ideas, and we have to do innovation, which is using ideas to create money. And we need to do both of them. And by the way, please don't use the word innovation at all if it doesn't have an economic dimension. If it doesn't have a business dimension, don't use this word. Use research. Right? And by the way, innovation is not necessarily about research at all. Not necessarily about research at all. If you remember the Pasteurs Quadrant, the Edison Quadrant, you can make a lot of business without doing sophisticated science. And Instagram and Facebook, okay? Okay, so of course it's not a startup. I lied. SAP Research is present in 22 worldwide locations, all over the globe. 700 researchers, including 200 PhD students. The ratio of research to development at SAP is, 700 researchers and about 15,000 in research and development. 60,000 total number of employees. Okay, so of course, when you're doing research at this scale, it's not like with a startup company where you have your couple of guys looking at something. You have more means to construct something more meaningful, something bigger. And you don't do it the same because SAP has a large client base. This is the model that we use at SAP from research to commercialization. We validate our research with prototypes with what we call SAP internal and external stakeholders. And these even can be customers. We have about 120,000 business customers in the world, so we can at least find 5 who are happy to play with some research prototypes and give some feedback, very valuable. This I like, this I don't like, etc., etc. And so we do that. And if there's enough traction, we go out and productize and eventually commercialize. That part is not on the shoulders of SAP Research anymore. But the first two are research and validation. Let me give you an example. Short video I'm going to show you. This is a prototype that we have. Anybody know of Siri on the iPhone 4S? You know of Siri? Okay. This is a Siri-like application, but for enterprise data. I shall add that one of our PhD students who has worked towards this prototype is present in the room, Raphael. And so, although he just defended his PhD successfully, his work remains in our prototype. So we know how to also do some transfer and make good use of the work of PhD students, collaborate with academia. So in this case, oops, I would need the sound. Is the sound possible here? Okay, I'm gonna be the sound.
How can I help?
Okay, yeah. How can I help? Said the
sales revenue of eFashion last quarter was $9,300,000. Would you like to know the revenue of your city, your estate, or your stores?
Of my stores?
The sales revenue for eFashion New York Magnolia in the last quarter was $1,170,000 and for eFashion New York Fifth $720,000.
The figures could be better. I wonder how...
Okay, never mind. I'm just going to stop here. So it's... Thank you, Bruno. This is just to show you that we are doing our own version of a question answering machine for the business user. In this case, the answer is not on the web, it's not on Wolfram Alpha or somewhere, it's in the enterprise data. What is the sales figure? It's a classic question. What is the margin? How many employees do I have in France? Blah, blah, blah. These are business intelligence questions. This is about the data. And so as you just saw, we have an application that does this voice activated. And so it's all about understanding natural language and also being able to restore the context of the user. Okay, this was just an example for you to understand that we're not just talking, we're really doing things. And so this might become a product later. I hope so. Okay, one thing SAP is very big about is design thinking. I think Julio mentioned it. Design thinking, I really recommend it to all entrepreneurs, has 3 components: business viability of your project, technical feasibility of your project, which comes second, and human desirability of your project, which nowadays I think is increasingly important, and maybe becoming the most important if you look at all these small applications being sold for $1 billion. Okay, so I encourage everybody to look up design thinking on the web and really understand what it means, because there are formal processes of design thinking, but the core idea is that you need to think along these 3 dimensions at once and not forget any. Okay, I'm almost done. And as I promised, my top 10 recommendations for entrepreneurs based on this experience that I had. The first and foremost and most important, you can almost forget about the 9 others, is begin with the end in mind. Identify the burning problem first. Classic drawback for researchers. Oh, I know how to do this and that. I did my PhD on that, so I think it's very good and must have excellent applications. Who cares? It's not about that. First, identify the burning problem. Second, have a clear focus, a value proposition. Don't do everything. How do you address the problem? In simple words, in one sentence. I think one of the other things about being an entrepreneur is being very pragmatic instead of theoretical. And so it's all about execution. Execute well. Not only vision, not only papers, not only equations. It's all about execution, really. Let's talk a bit about failure. Failure happens in research all the time. It's part of the game. It's why we do research and why sometimes we do fantastic things out of research. But when we are entrepreneurs, we need to fail early. We cannot afford to fail late in the process of development. Okay, so small experimentations, fail early. If you read about design thinking, you'll know all about failing early. Failing early is okay. Failing late is not. Improve continuously. This means, this is an obvious one, I guess. I want to add that it's important to have some doubts about what you do. We all have doubts. As scientists, I hope we do. Sometimes, we were discussing that over lunch, sometimes where you come from, your university, especially if it's an elite university or grande école here in France, they will not teach you how to doubt. Whereas you should doubt. You should doubt to improve all the time. Network a lot, talk about your project. I think this, since you came to this event, you already know that, but talking about your project, hearing about others, having some kind of intelligence about what's going on the market is hugely important. You cannot do your project in your room as a side project at night with Facebook on. You cannot do that. You need to network a lot in person. This is an important recommendation. Don't be too impressed. I think that's very important. If you're starting a company, sometimes you tend to be over-impressed by such and such VC who has $20 billion that he's managing, or you know, somebody else like me or somebody else who's, you know, has such a track record, it's impressive. No, don't be impressed. Do your thing. You should never be impressed. And as you are launching into unknown territory, sometimes being low profile researchers, you know, being modest in a good sense, sometimes people are impressed. Wow, this guy, he was the CTO of, you know, such and such company. Oh, he can certainly help. Not necessarily. Important one, I think, for everybody is do not settle when it comes to your team. Your team is the most important asset. It needs to be excellent. So do not say, okay, this guy looks good. He'll be a founder with me, or he'll be an employee. I think you need to be very, very demanding here. Communicate well. I think being brief and being crisp, hugely important. Hugely important. Practice about that. I think today with the internet and YouTube and everything, it's easy to look at the great communicators and learn from them how they do it, briefly, crisply. Elevator pitch, everything is very, very useful. Last one is an obvious one, be nice. But I read that people who are nice do more business than jerks, in summary. So being nice to others, being nice to your teams, being nice to people you meet, it increases your chances of doing good business. It's an obvious one. Okay, that's it. Thank you very much.
This was a very inspiring talk. Questions? Yes?
Hello, I'm Animesh Pathak. I'm a researcher at INRIA Rock&Core. Excellent presentation, especially like your last 10 tips. Number 8 is the one I want to ask about. It's a very valid point in my opinion about not settling when it comes to your team, especially when you're starting a company based on your idea, which is your baby, or of 3 other guys, and you want to make your first 10. Any tips on how to pick those first 10, or any mistakes you made?
I made a lot of mistakes. I can be specific and talk about my mistakes, okay? That's always better. Learn by example. Okay, I was approached early on by business people who were 15 years older than me and who were seasoned and looking for a challenge, blah, blah, blah. And I pushed back some of them. I didn't with all of them. Maybe I should have. Same goes with consultants. A lot of people will try to consult for you, but the consultant value added to you, it's 1 over X, 1 in time, right? So it goes down very, very quickly. So with a consultant, you should speak before engaging as long as possible and really see if it's still useful and pertinent after 3 months of discussion. These are very specific examples. I remember also hiring somebody without a degree for being a system engineer with us. It posed me a lot of problems. I don't want to go into them, but they make me smile looking back. So I would say that I think it's better to be lonely than with people that you don't fully trust. I think it's very important to be able to say, listen, I really trust these guys. I can go away on holidays, I can go and relax with my family, and it'll be taken care of. If you're not in that position, then you're not in good shape. I think that would be very, very important. I think you absolutely need that. You cannot be a control freak and say, oh, these guys are going to mess up, so I need to be in control all the time. So if you are in the position of giving them the keys and going to a weekend and visit your mom, then you're fine.
Also true when you have to it's maybe out of the line of this presentation, but you are director of research in SAP. Is it also true, this?
Which
Do
one?
you rely in your employees?
Oh, absolutely, 110%. But that's a management style, because you know, I think you work better in a good environment where people trust you, hopefully, and you trust people. Absolutely important, and that's a whole other topic of discussion, which is people development. How do you develop people who are not quite there? But that's a management discussion. Yes, I do absolutely trust my employees.
Any question online, maybe? No? Okay. Thank you very much, Chahab.